Welcome back to BAS 121. We're working on this regression analysis where we have multiple independent variables because it allows us to better explain or better forecast or predict our dependent variable. We started talking about the college university data. Remember, that's where we were trying to predict the graduation rates based on medium SAT scores, acceptance rate, expenditure per student in the top 10%. And we'll flip back to it real quick. We came up with an equation, the graduation rates, and all our p-values were less than 0.05. And we had a reasonably good adjusted R-squared, so we had a pretty good predictor. And then we looked at the banking example. In the banking example, we took a look at where we had a p-value that was a little outside the range. Initially, we had the home values, which were not a good predictor. So we went through the step of taking where our p-value was not good for an independent variable, taking it out of the equation, rerunning our analysis without that variable, and then coming up with a new equation without home value in the equation. Now we're going to talk about a concept called multicollinearity. And that's the formal definition. It's a condition occurring when two or more independent variables in the same regression model contain high levels of the same information. Now, in simple words, to me, a couple examples. Example number one, we've talked about how similar hypothesis testing was to the court system. Well, if you think about a court system, and let's say a child is on trial, and let's say as a character witness you bring in the mother, and then you bring in the father. Well, some people might argue that's really not two different or two really independent witnesses, because in most cases the father and the mother testimonies about their child in most cases is going to be very similar. So I think most people on the jury would say, I'm not going to weight that as high as two independent assessments. I might not weight the two parents' testimony as high as I might if the principal testified, the principal of the school, and another independent source might be the boss at the person's employment. So you get the school view and the employment view. It might be very different than the collinearity between two parents testifying. Or another example might be if I have data and I have one data point that's a person's income, and another one might be the amount of taxes they paid. Well, in most cases, all being equal, those would be very collinear, because for most of us, unless you have lots of deductions, as your income goes up, your taxes are going to go up. So it's really driving the same thing. Well, how do you determine if there's lots of collinearity? Well, so for the college data, and I put the raw college data down here, it's as simple as you go to data analysis, and you go to correlation, and you put in your data. Now, you have to put in numerical data. You can't put in the fields that are categorical data. And you put it in, and this is what you get. And what you're looking for is any of these areas. This is the collinearity between medium SAT and acceptance rate. Now, obviously, acceptance rate's going to be 1. Expenditure per student and medium SAT. You can see if they're correlated or not. And a rule of thumb that the book gives us is you don't want this score to be higher than 0.7. So the absolute value of it. So in the college data, none of our independent variables were collinear. So in other words, none of them were really saying the same thing. We did the same thing for the banking data, and look what we found out. Income levels and the amount of wealth a person had were very collinear. And you think about it, and that might make some sense. Well, if I have a high income, most likely I have a lot of wealth. Now, it's not always the case, but certainly this is higher than zero point 0.9. So is, I didn't circle it, so is income and home value, right? So, bottom line, we might want to go back and take one of these variables out. Like we might want to take one of these income and wealth, we might not want to have both of them in. So you'd redo it and take maybe the, you'd play around with it. I took the wealth out of here because income and wealth, I felt were saying the same thing. Income and wealth, highest collinear, multicollinearity is between income and wealth. So I decided to take wealth out. So I came down here. We'd already taken home value out. I reran this without wealth in there and reran my regression statistics. Notice I get p-values all less than, well, I still don't have it. I still got education. So we'd probably have to do a little bit of rerunning here. But you'd come up with a very different equation and you'd take out the situation where you have the collinearity. It's basically where you're testing to make sure I don't have two independent variables that are basically saying the same thing. That's multicollinearity and how to test for it and to take it out of your models. Any questions? Let me know.